Hello, everybody. This is Bashar Alhafni, and I'm a computer science PhD student at NYU. I'm excited to present our work on strategies for Arabic readability modeling. This is joint work with my colleagues Juan, Muhamed, and Nizar. The task of automatic readability assessment refers to determining the reading comprehension difficulty level of a given input text according to a specific scale. So for instance, if the input text was hard to read, the text will be assigned to a high readability level. And in this case, it got level 5. Whereas if the text is easier to read, it will be assigned to a lower readability level. Now, in our work, the readability level of a given text depends on the difficulty of the words that are in that text. The task of automatic readability assessment has many applications, either human-facing applications or machine-facing applications. For the human-facing applications, it could be used to support readers with learning disabilities or in choosing appropriate reading materials for language teaching. Whereas for the machine-facing applications, it could be used, for example, to control the output of NLP systems like machine translation or text simplification to ensure that the outputs are appropriate for the target audience. However, most research on automatic readability assessment has focused on English in terms of both dataset creation and modeling approaches. In our work, we explore the task of automatic readability assessment for Arabic by using a diverse set of approaches. We report results on a newly created corpus at both the word and fragment levels, and we highlight the strengths and weaknesses of each approach. We show that combining different modeling techniques yields optimal results. Now, I will present a brief overview on Arabic linguistic facts. So Arabic is a morphologically rich language that inflects for gender, number, person, case, and so on. There are 22,400 possible part-of-speech tags in Arabic compared to the 48 part-of-speech tags that are used in English. Each Arabic word could have on average up to 3 different core meanings or 3 different lemmas. Arabic is also orthographically ambiguous because it uses optional diacritics to specify short vowels and consonantal doubling. And each Arabic word could have on average 3 different diacritization. So for example, the word in this example could be read as darsuha, meaning her lesson, darasaha, meaning he taught her, or darasaha, meaning he studied it. And each one of these words has its own lexical item. Now, this example highlights the importance of automatic readability assessment and building applications that could be used for Arabic language learners. Now, the SAMR project is a project that is funded by an NYU Abu Dhabi Research Enhancement Fund to create resources for the simplification of Arabic fiction to target school-age learners. Over the past few years, the project has developed many open source resources. So we have a readability lexicon, a readability thesaurus, a simplification interface, and a simplification corpus. And in our work, we use the newly created SAMR Arabic text simplification corpus. The corpus was manually annotated for Arabic text simplification, and it contains 159,000 words selected from 15 publicly available Arabic fiction novels. Now, the goal in this corpus was to simplify the Arabic fiction novels so that they can be targeted towards school-age learners. Now, to ensure that the simplified texts were appropriate for the target audience, the authors of the corpus relied on the 5 readability levels that were defined by Khalil et al. When creating the SAMR lexicon. Now, the SAMR lexicon is depicted in this example. It is a lexicon that consists of 40,000 lemmas, where each lemma was manually annotated with a level from 1 to 5, reflecting the difficulty of that word. Now, these levels corresponds to the proficiency that is needed to basically understand and comprehend these words. So level 1 corresponds to grade 1, level 2 corresponds to grades 2 and 3, and level 5 corresponds to a specialized level for example. And in the SAMR corpus, the readability level of the document was defined to be equal to the highest readability level found among the words in the document. And given the nature of the documents in the corpus, all of them will have a readability level of 5. Now, in the corpus, each document was simplified to 2 levels, level 4 and level 3. In terms of the readability level annotations, the corpus release contains annotations at the word, document, and fragment levels. And fragments over here refers to segments that were determined in an ad hoc fashion by using punctuation. Now, in our work, we model readability assessment of the original text on 3 levels. So levels 5, 4, and 3 at the word and fragment levels. Moreover, we employ a more generic approach to obtain word-level labels in the original text. We align the original fragments with their levels 4 and levels 3 simplified texts. And then we derive the word level labels based on whether the words in the original text changed when simplifying to the level 4 or level 3 simplified parallels. So for example, the word فأشارت in yellow over here got a label of 4 because it changed when simplifying level 4 to level 3. Whereas the word in farabad got in red over here got a level of 5 because it changed when going from the original text to level 4. Whereas the remaining words in green got levels 3 because they didn't change across the 3 parallel fragments. In terms of the splits, we use the splits that are included in the release of the corpus. So for training, we have 14,000 fragments, and for development or dev and test, we have about 3,000 fragments in each split. For our modeling approaches and starting off with the word level models, we have a maximum likelihood estimation or an MLE model. It's a simple word level lookup model that was built based on the training data. Our second model is the lexicon model or the Lex model that basically relies on the SAMR lexicon. And for this model, during inference, we first perform a morphological disambiguation in context to obtain the lemma and part speech tag for each word before we look them up in the SAMR lexicon to obtain their readability levels. For the third approach, we rely on 2 frequency-based models. And for these models, we derive type frequency data from a large corpus of Arabic words that has about 11 million types. And we label these types by using 2 approaches. So we have the distribution-based labeling or dist-fric. In this approach, we divide the types into 3 bins based on the distribution of the readability levels in the training data. For the second approach, we have example-based labeling or xfric, where we divide the types into equally sized bins, and each bin will be labeled according to the majority readability level of the training words that were found in that bin. Now, for these 2 approaches during inference, we basically look up the words in each of the bins, and then we'll assign them to the readability level of that bin. For the fourth modeling approach, we fine-tune Camel-Bird MSA to build a word-level classifier. And lastly, we experiment with combining all of these systems together in a cascaded back-off mode, and we end up with 24 system combinations. For the fragment level models, we first rely on aggregating the word level predictions. And over here, we use the word level models to predict the fragment level labels. And the fragment labels would be equal to the highest readability level that are found among the words in that fragment. For the second approach, we fine-tune Camel-Bird MSA to build a fragment level classifier. For our results, and starting off with the dev results at the word level, we first present the results on the models that don't really suffer from out of vocabulary, and out of this set, BERT was the best performer with about a 74.6 macro F1 score. For the second set of results, we present both the MLE and the lexicon or Lex model with a cascaded setup with the models that are presented in the first set. And out of these two setups, we see that the lexicon followed by BERT achieves the best performance with 86.5 macro F1. Now, lastly, we experiment with using both the MLE and the lexicon in a cascaded setup, followed by BERT. And we noticed that when tuning the confidence threshold in the MLE model, followed by the lexicon, followed by BERT, achieves the best performance overall with 87.9 macro F1. Now, at the fragment level, the tuned MLE followed by the lexicon followed by BERT also achieves the best performance of 87.9 macro F1. Now, at the test results, we also observe a consistent conclusion at both the word and fragment levels, where the tuned MLE lexicon BERT model achieves 86.7 macro F1 at the word level and 87.9 macro F1 at the fragment level. Now, in terms of the error analysis, we conducted an automatic analysis of the word level decisions that were taken by each of the components in our best performing system on the dev set. And we see that the majority of the decisions were made by the MLE model, which has the highest error rate at both the word and the fragment levels, followed by the lexicon, followed by the BERT model. We also conducted a manual error analysis of about 100 cases of errors from the def set, and we classified these errors into 7 distinct error types. So we have input errors, and these refer to malformed inputs. We have gold annotation errors, and these refers to basically things that were simplified in the summary corpus that should have not been simplified. And then we have goal determination errors. These are errors that are due to the generic algorithm that we followed to label the words. And then we have MLE model errors, followed by disambiguation errors. And these are attributed to the model that we used to obtain the lemma and the parse speech tags of the words when we use the SAML lexicon. And lastly, we have lexicon errors and then followed by BERT errors. And in conclusion, we explored the task of automatic readability assessment in Arabic by using a diverse set of approaches. And we reported results on a newly manually created corpus at both the word and fragment levels. We highlighted the strengths and weaknesses of each approach, and we showed that combining these approaches together yields the best results. In future work, we will explore the effect of various linguistic features in enhancing models for Arabic readability assessment. And we plan also on developing online tools to support pedagogical NLP applications. Thank you so much for listening, and please let us know if you have any questions.